So you would start the same way. And the connection between algebra and polynomials and, say, the numbers we were doing before. I'm just going to steal some of the numbers we were doing before. 2748 divided by 13. 2748 would be no, I've got them all, too many numbers here. 2x cubed plus 7x squared plus 4x plus 8. Can you see that if x was equal to 10, then this would be 2748. Okay? So that's sort of our idea of why it's connected to the long division that you did before. We can think of this number as 345, and your long division is divided by 8 if x were 10. And what happens is the same idea is, and we had here, we look, does this number 13 fit nicely into the 2? How many would you need? And if it doesn't, then you would go to the next one and see how it fits in for the next one. What we're going to do here is we've got 3x squared minus 4x plus 5. We ask ourselves, well, what would I have to multiply this by, this x minus 2, to get a 3x squared? Could you see if I multiplied that x minus 2 by a 3x, I would get a 3x squared? So what I do is I write above the x column a 3x. And I multiply that 3x by the x minus 2, and I'll get 3x squared minus 6x. Because that's what you would get if you multiplied that 3x times the x minus 2. And what we're going to do is we're going to subtract that, just like we subtracted before. And that will leave us with 0 x squareds left. But negative 4x minus a negative 6x will be plus 2x. And then 5 minus nothing would still be plus 5. Now, what would you have to multiply an x minus 2 by to get a 2x? So again, you're always looking. First, we looked at the first term, which was the 3x squared. And we found out we would have to multiply by a 3x to get that. Now that we've subtracted, our first term is a 2x. What would we have to multiply our x minus 2 by to get a 2x? We would have to multiply by a 2. I'm going to switch colors. So it's color-coded. Now when I multiply that 2 by the x minus 2, I get 2x minus 4. And if I were to subtract, 5 minus a negative 4 is 9. And that becomes my remainder. So 3x squared minus 4x plus 5 divided by x minus 2 gives us 3x plus 2, remainder 9. Let's do this one. We have an x plus 1, 2x cubed minus x squared minus 2x plus 1. So again, we look at the biggest term, which is the 2x cubed, and ask ourselves, what would I have to multiply my x plus 1 by to get a 2x cubed? A 2x squared. So I'll write 2x squared above the x squared column. It's sort of like holding your place values like we did before with the real numbers. And 2x squared times by x plus 1 would give me 2x cubed plus 2x squared. See what I'm doing here when I'm multiplying? I'll do it off to the side here. 2x squared times by an x plus 1. You would have to distribute. And that would give you 2x cubed plus 2x squared. Now when I subtract, so I always put it in brackets so I remember to subtract all of it, this becomes 0. Negative x squared minus 2x squared would become minus 3x squared. And the other ones would just come down because there's no like terms when you're subtracting. Switch colors. Now our biggest term is a negative 3x squared. You just do the same thing over and over again. That's in math is called an algorithm because you just repeat things over and over again until you're done. So now with negative 3x squared, what would I have to multiply my x plus 1 by to get a negative 3x squared? I need a negative 3x. And when I distribute that, I'll get negative 3x squared. Negative 3x times positive 1 would be negative 3x. And I'm going to subtract. So give me 0. Negative 2x minus a negative 3x will be plus x. Bring down the 1 plus 1. And what would I have to multiply x plus 1 by to get x plus 1? 1. Positive 1. That'll give me x plus 1. And when I subtract 0, 0, this one has no remainder. And it works out perfectly. What that means when it works out perfectly, and a little bit of foreshadowing of what we're going to be doing in this unit, we just figured out from this dividing that 2x cubed minus x squared minus 2x plus 1 is equal to bracket x plus 1 times by 2x squared minus 3x plus 1. What does that mean? What does that look like we're doing? It looks like we're factoring. In fact, something that you didn't know how to factor before, now we get closer to factoring. In fact, this one, you already know how to factor. It would be 2x and x, 1 and 1. Both of those would be negative. Now we've factored it completely. Yes?